Function arithmetic. Functions can be added, subtracted, multiplied, divided, just like polynomials, to obtain new functions. Domain of the new function is comprised of domains of original functions, excluding any values that make the new function undefined. So to obtain the addition function, we can go ahead and add the individual functions. To obtain subtraction function, subtract the individual functions. Be careful if you're subtracting a binomial. Don't forget to include parentheses and distribute the negative sign into entire second function. To obtain a multiplication function, we can multiply the individual functions. And same way, division function can be obtained by dividing the two individual functions. Keep in mind the denominator should not equal 0 for the domain restrictions. If we have a rational function, we do not want the denominator to be equal to 0 because that would mean that function is undefined. Difference quotient of functions is f of x plus h minus f of x divided by h. So difference quotient is used to calculate the limits. We'll talk about that later. Today we will learn how to calculate the difference quotient along with the arithmetic on the functions. First example, we are given f of x and g of x, and we are looking for these following parts. So for part A, f plus g of x, we are just going to add the individual function f of x plus g of x, and that gives me x squared minus 8x plus x plus 12. Let's combine the like terms. Negative 8x plus x will give me negative 7x plus 12. To get the subtraction function, be careful that we have to include parentheses because we are subtracting the entire second function from the first function. It comes up with x squared minus 8x minus x minus 12. Combining the like terms, we are left with x squared minus 9x minus 12. To obtain the multiplication function, f times g of x, so f function is x squared minus 8x, g of x is x plus 12. We can either use distributive property or foiling and then combine the like terms. Comes out to be x to the third plus 12x squared minus 8x squared minus 96x. And we can combine the like terms here. That would be positive 4x squared minus 96x, and that's our new function. Because original functions had the domain negative infinity to positive infinity, each of these will have the domain negative infinity to positive infinity because there's no domain restrictions on the new functions. Let's talk about division function now. To obtain f over g of x, we can divide the original functions in x squared minus 8x divided by x plus 12. But we want to make sure that the denominator is not equal to 0, so we must exclude the value negative 12, because if x ever becomes negative 12, then my denominator is going to become 0, and that's going to make the function undefined. That's all for adding, subtracting, multiplying, dividing the functions. We add, subtract, multiply, divide just like the way we do to polynomials. Now for part E, we can actually do it in two different ways. We already found f plus gx. We can replace the x by 3 in there, or we can find f of 3 and g of 3 and add them up. So I'm going to use the part A, the function we actually found in part A, and replace the x by 3. So for part E, f plus g of x is equal to x squared minus 7x plus 12. And we can evaluate this function at any value of x, which in this case we want to evaluate at 3. So we can replace the x by 3 on both left and right hand side. That comes out to be, that would be actually 0. So we have 0 here, and next example is f of x is 2x squared plus 3x plus 1. We want to find f of negative 3 plus f of 1. So let's first find f of negative 3, which it means we're going to replace x by negative 3, and that turns out to be 2 times 9 minus 9 plus 1. 18 minus 9 is 9 plus 1 is 10. And then we want to evaluate f of 1, which is 2 times 1 plus 3 plus 1, which is 6. F of negative 3 plus f of 1, we can add and figure out that's going to be 16. Next example, f of x is 3x squared plus 4x minus 1. Find the difference quotient. So difference quotient is f of x plus h minus f of x divided by h. So I'm going to first find out f of x plus h. We're going to replace every single x by x plus h in here. So that would be 3 times x plus h squared plus 4 times x plus h minus 1 minus f of x, which is 3x squared plus 4x minus 1 divided by h. All I'm going to do is simplify a little now. That would be x squared plus 2xh plus h squared plus 4x plus 4h minus 1 minus 3x squared minus 4x plus 1 divided by h. Let's go ahead and distribute the 3 and see if there's any terms that cancel. 3x squared plus 6xh plus 3h squared plus 4x plus 4h minus 1 minus 3x squared minus 4x plus 1 divided by h. Let's cancel any common terms that we can cancel, any terms that are positive and negative, but same terms, so they're going to be gone from here. We have positive 4x, negative 4x, we have a negative 1 and a positive 1. So all we're left with is 6xh plus 3h squared plus 4h divided by h. We can factor an h out from the numerator and be left with our difference quotient, and that would be 6x plus 3h plus 4. And that's our difference quotient for this problem. Okay, another example. In Sutter County, speeding fines are determined by this function. So this function gives me a relationship between the speeding fine and the speed, where f of s is the cost in dollars of the fine when a person is caught driving at a speed of s miles per hour. Find the fine if someone is caught driving at 85 miles per hour. So this is the speed given to me, and I'm going to replace it with the s in the given function. This f of s simply means the function, the fine depends on the speed. Fine when the speed is 85 is going to be 10 times 85 minus 30. 85 minus 30 plus 60. So that turns out to be 10 times 85 minus 30 is going to be 55 plus 60, which is 550 plus 60, and that would be 610. So the dollar fine would be $610 for the person who was driving at 85 miles per hour. If the fine comes out to be $310, what speed was the person driving at? So now this given amount is the fine, and we are looking for the speed. So I'm going to replace it with the fine in the equation that's given to me for the function. 10 times s minus 30 plus 60. 310 would be 10s. Let's distribute. Minus 300 plus 60. 310 equals, so we can go ahead and combine the like terms. So that would be 300, that would be negative 240. 310, negative 300 plus 60 would be negative 240, and we would add 240 to both sides. 310 plus 240 is equal to 550. So 310 plus 240 is 550 is equal to 10s. Divide both sides with 550. Divide both sides with 10 to isolate the s, and the speed turns out to be 55 miles per hour. Do not forget the units with each problem. That's all for this video.